For this video, we're going to discuss finding the least common denominators and writing equivalent fractions for rational expressions. Okay, we've already discussed rational expressions, that they are fractions with variables in them. And so we're going to look at how can we rewrite these. Remember that we need least common denominators in order to add or subtract fractions, rational expressions, that type thing. So when we're writing equivalent fractions with the common denominators, the first thing that we need to make sure is that we factor all the denominators completely. That means get them into their prime factors, factor out greatest common factors, factor out a -1 to make them the same, that type of thing. Then the LCD is the product of the unique prime factors. So in other words, wherever there's a factor, we have to have it in the least common denominator, least common multiple, okay? Once we've found the least common denominator, then we can multiply the numerator and denominator of the original fractions by what is missing. Now I know that doesn't make a lot of sense, so let's look at some examples, okay? So the first example is 7/36 and 5/24. So let me first come over here and look at 36 and 24. We're going to factor these into their prime factors. So 36 can be 6 times 6. Those are still not prime. So 6 is 3 times 2 and 3 times 2. So 36 actually factors down into 2 squared, because I've got 2 2's, times 3 squared, because I've got 2 3's. Now we're going to do the same thing for 24. That's 8 times 3. That's a 2 times 4. And 4 is 2 times 2. So notice with 24, I actually have 3 2's and 1 3. Now the thing about common denominators is it's the highest power of any factor, okay? So if I look at this, the highest power of 2 is actually going to be 3. So my least common denominator is going to have a 2 to the third power, and my exponents for my 3 are either 2 or 1, so I'm going to use the 2. So my least common denominator, whenever I multiply this out for this particular problem, is going to be 72. So both of these are going to become a denominator of 72. Okay. If we look at the 36 here and we say, okay, what's the difference between this least common denominator and this denominator? There's 2 3's, which is okay. The denominator has 3 2's and this only has 2 2's. So that means I'm going to multiply the numerator and denominator by 2. That's what gets me the 72. So 7 times 2 is 14. So now I have 14/72, which is the equivalent of 7/36. This one is just the simplified version. Now if I look at the 24, notice I have 3 2's, which is the same as the least common denominator. I only have 1 3. So that means I need to multiply the denominator and numerator by a 3, giving me 15/72. Now I have common denominators, and I could add or subtract based on what is required. In this particular one, we're just rewriting the expressions. Okay, let's look at another example. This one has variables in it as well. So I'm going to start off. I will actually come over to the left-hand side and look at the first denominator, which is 3s squared t. Now if I factor that completely out, 3 is a prime number, so I don't have to worry about the 3. if I look at it, s squared is the same thing as s times s, and then I have a t. Okay? Now looking at the 6, st to the 4th, now 6 is not a prime number. 6 is a composite, which is made up of 2 times 3. Then I have an s, and I have 4 t's. Remember, that's what the exponent means. So whenever I go to find my least common denominator, so I'll come over here, least common denominator. Notice they both have a 3, so I'll write it down. They both have an s, so I'll write it down. They both have a t, so I'll write it down. Notice my first one also has another s, so I actually have to write it down. And my second one has an additional 2 and 3 more t's. Okay? Now this is going to help me because my least common denominator, 3 times 2 is 6, so that's 6. I have 2 s's, and I have 4 t's. Now notice my s's, the largest exponent is a 2, and my t, the largest exponent is a 4. That's what comes down here into my least common denominator. Okay, now looking at this first one, what I'm missing between here and here were these values, a 2t to the 3rd. So I'm going to multiply the numerator by a 2t to the 3rd, which is the same thing as what I've done to the denominator. That should be a 2t to the 3rd. So 5 times 2t to the 3rd gives me a 10t to the 3rd. Now on this denominator, the thing I'm missing is my red letter, my s. So I'm going to multiply numerator and denominator by an s. That's where I get the s squared here. And I have a 7s. Now that I have common denominators, again, I could add or subtract as needed. Now let's look at some with polynomials in them. The polynomials, we have to be careful because we have to make sure that we factor the denominators completely first. So let's look at y squared minus 9, my first denominator here. Y squared minus 9, that is a difference of squares because I have a square minus, and a 9 can be written as 3 times 3. Okay? If you need to, remember, you can put a plus 0y in there, and then find factors of a negative 9 that add up to a 0, which would be negative 3 and positive 3. You could do factor by grouping, or since there's no leading coefficient, I can do y minus 3, y plus 3. So this is the denominator for this. Let me go ahead and rewrite it for y minus 3, y plus 3. Okay? Then I'm going to come over here and look at the y squared minus 6y plus 9. So I need factors of a positive 9 that add to give me a negative 6. Well, positive 9 is either going to be positive 3 times positive 3 or negative 3 times a negative 3. The pair that add to give me a negative 6 is going to be that negative 3 times a negative 3. And again, since there's no leading coefficient, I can have y minus 3, y minus 3. So if I rewrite this, I have y minus 3 on the denominator, and I have a 7 on the numerator. So now then, looking at these, finding a common denominator, well, I have a y minus 3 in both of them, so that's going to be easy. Then In this one, I have another y plus 3. And in this one, I actually have a y minus 3. Okay. So notice where I rewrite the denominator for both of them, and I go through, and notice I'm not multiplying the denominators back together at this point because I'm going to be adding or subtracting. So from this fraction, what I'm missing is the y minus 3. So I'm going to multiply the numerator by a y minus 3. So I get 4 times y minus 3. On this one, notice I'm missing the y plus 3. So I'm going to multiply by a y plus 3. So I'll have 7 times a y plus 3. Now the numerators, I do want to go ahead and multiply back together. So I'll end up with a 4y, and what I'm doing is I'm distributing. 4 times y is 4y, 4 times a negative 3 is a negative 12. And then I'm going to keep my denominator factored out. Y plus 3 and a y minus 3. Now on the second one, 7 times y gives me 7y. 7 times 3 gives me a positive 21. And I have the same denominator, y minus 3, y plus 3, y minus 3. So now then, we actually have common denominators, and again, we could multiply or divide, I'm sorry, not multiply or divide, add or subtract as need be, that we have the common denominators. Okay, let's do one more. This one has 5 over d minus 6 and a 10 over 6 minus d. So let's look at these. 5d minus 6 and 10 over 6 minus d. Now these denominators actually look very similar. They both have a 6, they both have a d, and they both have a subtraction. But if you notice, in this one, the 6 is negative, but over here the 6 is positive because there's no sign in front of it. And in the first one, the d is positive, but here the d is negative. So literally they have opposite signs. Now, as I've said before, I prefer to have the variable be positive and in the front. So if I rewrite this one, I will get negative d plus 6 as my denominator. And I'm going to factor out a negative 1. So I'll have a negative 1 times a d minus 6. Because remember, if I factor out a negative, it changes the signs of both of those. So now the d minus 6 actually looks the same. The only difference is this negative 1. So my common denominator is going to have a d minus 6 in both of them. But it also needs this negative 1. So I'm going to multiply both numerator and denominator by a negative 1. So that's going to give me a negative 5 over a negative 1 times d minus 6. And this one stays the same, 10 over negative 1 times d minus 6. Now my denominators look the exact same, and I can add or subtract accordingly. Okay? Try getting the least common denominator of rational expressions, and let me know if you have any questions.